PCB circuit boards are used in almost all electronic products, ranging from aircraft and rockets to headphones and watches, and other electronic applications are inseparable from PCB. Hardware engineers deal with PCB and PCB design every day, so what process does PCB go through, or how does PCB itself change from raw materials to what we look like in our design files step by step? What has this process gone through? So today we will show you step by step through a series of animated pictures. Gerber input. To make a qualified PCB, you must first input the Gerber file. Then the factory cannot process the customer's Gerber file directly, which will cause great risks. Factory engineers will use DFM software to perform some optimizations based on their own factory manufacturing capabilities. Of course, the optimized parameters must be communicated with customers to see if they meet the design requirements. PCB panel. Panelization combines multiple independent PCB boards to form a larger PCB board. This method can simultaneously reduce size, reduce manufacturing difficulty, reduce manufacturing costs, and improve quality controllability. Imposition is not only for aesthetics and increasing patching efficiency, but also to meet production needs. Some PCB boards are too small and do not meet the requirements for fixtures, so they need to be put together for production. Usually, process margins will be added during the imposition, and experienced PCB engineers will also optimize the utilization of the board for you, especially when it comes to special-shaped boards. The main purpose of imposition is to maximize the utilization of panels and thereby reduce costs. Board cutting. PCB boards are generally 2089 by 1246 double-sided copper-clad laminates. There are many types of copper foil thickness. Generally, the copper foil thickness is 0.035 mm. The interlayer material in the middle of the copper foil is usually composed of epoxy resin and glass fiber cloth. This is what we often call FR4. In addition to the substrate materials, there are other materials such as aluminum substrate and copper substrate. The substrate will be cut into the materials we need through a machine called a cutting machine. Then the four sides will undergo a series of polishing. Drill positioning holes. Before the plate enters subsequent production, positioning holes need to be drilled on both ends of the plate. The purpose of the positioning holes is for the equipment to fix and identify the relative position of the plate during the subsequent processing. Drilling. PCB boards need to drill three types of holes for different purposes. 1. Screw holes for fixation. 2. Reserved holes required by customers. 3. Via hole for user line conduction. The automatic drilling machine will automatically select and replace drill bits of different specifications according to requirements for drilling operations. The smallest drill bit can reach 0.2 mm. Grinding board. The main function of grinding plate, basic pre-treatment, is mainly to solve the problems of surface cleanliness and surface roughness. Remove oxidation and increase the roughness of the copper surface, making it easier for the film to adhere to the copper surface. Plated through hole. The purpose of copper deposition is to use the principle of chemical reaction to deposit a layer of 0.3–0.5 copper on the whole wall to make the originally insulated whole wall conductive, which facilitates the smooth progress of subsequent board electroplating and pattern plating, thereby completing the PCB circuit electrical interconnection between networks. Lamination plus exposure plus development. Lamination: apply dry or wet film to the processed substrate by hot pressing or coating to facilitate subsequent exposure production. Exposure: align the negative with the substrate on which the dry film is pressed, and use ultraviolet light on the exposure machine to transfer the negative pattern to the photosensitive dry film. Development: use the weak alkalinity of the developer, sodium carbonate, to dissolve and rinse away the unexposed dry film/wet film, leaving the exposed part. Electroplating plus etching. Why is electroplating needed? After the above process, the copper foil that needs to be left on the copper-clad board has been completely exposed. The electroplating process is to first coat the exposed copper foil with a layer of tin to prevent the copper foil that needs to be retained from subsequent etching. Was scratched in the process. After electroplating, the board will go through a film stripping machine to clean off the previous coating, and then the copper foil that does not need to be retained will be etched away, and the copper foil that was previously tin-plated will be retained. Finally, it goes through the tin stripping machine to wash away the tin. What is left is the copper foil we need. Automatic optical inspection (AOI) plus impedance testing. Use AOI equipment to optically scan the produced PCB motherboard, and then compare the scan results with the customer's original design to ensure that the PCB circuit board fully meets the customer's requirements. Impedance testing to ensure the continuity of each line, to further ensure the quality of the PCB. Solder mask plus silkscreen. Solder mask refers to a layer of green oil that needs to be applied on the printed circuit board. Other colors are also available according to customer requirements. The main purpose of the solder mask layer is to prevent oxidation, prevent bridging during soldering, and act as an insulator for the PCB board. There are many wires and pads on the board, which can cause short circuits if they are not properly isolated from each other. Solder mask covers the area between the wires and pads, reducing the risk of shorts. On a circuit board, without proper isolation between wires or between pads, electrical signal interference and leakage can result. The solder mask provides electrical insulation, reducing the possibility of leakage and electrical interference. The solder mask layer can provide a layer of protection to prevent components on the PCB surface from being corroded or damaged by the external environment, such as dust, moisture, etc. This helps improve the reliability and longevity of the circuit. Silkscreen can be used to identify the location, value, model, and other information of electronic components, as well as the orientation and correct installation method of the components. This is critical for assembling and servicing circuit boards, and helps operators properly understand the board's design and layout. The PCB board is basically formed. Next, it needs to undergo a flying probe test to test the continuity and short circuit of the PCB. Then it is divided into boards or V-cut, and then cleaned again, and finally packaged and sent to the customer. The above various processes have covered most of the manufacturing steps from substrate to PCB. Finest Printed Circuit Board Limited is a professional one-stop PCB and assembly service manufacturer with 20 years old. We have 8 large SMT line to support your PCB projects. Ready to explore PCB assembly options for your project? Start by contacting a few reputable providers for quotes. Remember, it's not just about the cost. Consider factors like quality, reliability, and customer service when making your decision. If you have any request for PCB and PCBA production, please send us your file to email inquiries@feinst.com.